All right, so like we saw in the last example, sometimes we need multiple arrows to show what's going on. So let's take another example of this. So here we have this nitrogen with its lone pair. We can think about moving this nitrogen lone pair over here. But if you do that, think about what the structure is going to end up being. If you take a look at this central carbon right here, now it has 5 bonds. That's not okay, right? Carbon can only form up to 5 or up to 4 bonds. So we can't do this resonance structure. However, this structure does indeed have resonance, right? It does have valid resonance structures. It's just that we need 2 arrows to show it. So we could move these electrons over here and then move these pi electrons onto the actual carbon itself. To end up with something like this, right? And then to go back from the right to the left, we would simply move this lone pair back onto this bond right here, and then move the pi electrons back onto the nitrogen, right? So this bottom one is okay. Notice though that our formal charge is also changing, right? On the left, we had no formal charge, and now we've got a positive and a negative. And so that's another thing that we have to really keep track of and get good at. So keep track of formal charge. And it's too time consuming to calculate the formal charge on every single atom on every single resonance structure. So what we can do is just look at the change of formal charge, right? So if something gains electrons, it's going to get more negative, right? So for example, this carbon right here gained electrons, and so it became negatively charged. If something loses electrons, it's going to get more positive. And we're only ever going to move in charge of plus or minus 1, right? So we're going to go from 0 to plus or minus 1, never plus or minus 2 or anything crazy like that. So you can see this nitrogen lost electrons, right? It had a lone pair. It had 2 electrons to itself, and then it went to sharing those 2 electrons. And so it lost electrons, so it got more positive. Let's take another example or another look at this. Right, we have this structure right here. And then the first thing you have to realize is that this oxygen does indeed have lone pairs, right? It has lone pairs. And so it can resonate here. We could move these lone pairs down here and then move the pi electrons onto this carbon. To get something that looks like this, right? And so this oxygen donated some electrons, so it lost electrons. So it's going to go from being neutral to now being positive. And then on the other hand, this carbon right here gained electrons. It went from sharing electrons in a bond to having both of those electrons by itself. And so now it's going to have a negative formal charge. And it still has a filled octet, right? Remember that this hydrogen is here in both of these structures. It's just not shown. We can take a little shortcut too. We don't even have to draw these lone pairs in some instances. We can start our arrows at negative charges. So for example, if you have something like this, you could draw a resonance structure like this, right? Move those electrons there. But you could also draw this structure just like this, right? Now I've omitted these lone electrons. I haven't drawn these lone electrons. That's totally fine. Remember, we don't have to draw these. And so I can just start my arrow at a negative charge, and that implies that they're coming from a lone pair. And then just move it up here. And so these two are exactly the same thing. right? And they both end up with the same resonance structure of this guy right there. We can only do that, though, if we have a negative charge. If you're neutral, you must draw your arrows from a lone pair. And so you have to explicitly put the lone pair in. So for example, if you have a structure that looks something like this, you cannot just say that these lone electrons move from here to down here. You cannot do that. You must explicitly show the lone pairs. You don't have to show both of them. You can just show one of them, but you have to show a lone pair, right? That moves there, then that moves there, and then we get a nice resonance structure. Right? We get that structure right there. And so at this point, you really want to stop and do some practice, right? Go through the work along sheet. You have the key for it. You have the worksheet. Do some practice problems. You'll start seeing some common things showing up again and again and again.